Hello friends, very good evening. Myself Dr. M.H. Chennaya, and in today's video we are going to learn the development of a square pyramid which is resting on HP on its base. Let us see what is the question we have in store for today's video. The question reads like this: a square pyramid of side of base 30 mm and height 65 mm resting on its base on HP with a slant edge parallel to VP. So, friends, first of all, let us see how this pyramid is. It is a square pyramid having four triangular faces on its lateral surface, a square base. And if you observe the top view, friends, you have got four slant edges: OA, OB, OC, OD, etc. And it is said in the question it is resting on HP such that one of the slant edges is parallel to VP. So this OA is one of such slant edges, OC is one such slant edge. So we have to place the object on HP such that all the four base edges of the pyramid are equally inclined to VP. That is at an angle of 45 degrees. So friends, what I do, I write a square in the top view with all the sides making 45 degrees with the VP, or two sides making 45 degrees with VP. It is one and the same. So this is 45 degree. The dimension is 30 mm. It has got a side of 30 millimeter. I will say 30 SQ. SQ indicating it is a square of 30 millimeter side. And the height of this is given as 65 millimeter. So I will write a line here and show the height as 65 mm. So friends, this is the XY line, the line of intersection of VP and HP, and we are solving the problem in first angle projection. And friends, after writing this, let us name these corners as A, B, C, D. O is the vertex and O dash is the vertex in the front view. O1 is the center of the base, and this is O1 again in the at the center of the bottom face. And see how it is cut, friends. Now it is cut by two section planes, not one, two section planes, both being perpendicular to VP. Friends, whenever a section plane is perpendicular to VP, it is always seen as a line in the front view. So this solid in this position is being cut by two section planes. One is horizontal. I call that as S1, S1, and the other one is S2, S2. Section plane, one of them is horizontal. So S1, S1 indicates a horizontal section plane. Whereas the other section plane and the other is parallel to the slant edges and sloping to the right. So friends, this is the slant edge O dash A dash, and this is the section plane S2, S2, which is parallel to this, and both of these meet at the midpoint of the axis. That is to say, friends, we have to take half of this, that is 32.5 millimeter, as the distance from the base of the solid till the section plane S1, S1, and this S2, S2 is parallel to O dash A dash, and O dash A dash is one of the slant edges, and that is parallel to VP as per the question. Now friends, how to draw the projections of the development of this? After it is being cut by two section planes, the portion below this, which I have shown here, is the portion for which you have to draw the development. So friends, what we do, we assume that the solid is not cut by any section plane, and hence we obtain four triangles on the lateral surface, and all these are isosceles triangles having base equal to 30 mm. All these bases are 30 mm each. That is the length, straight edge length is 30, 30, etc. Now if you observe the front view of the solid, friend, you find that none of the slant edges OA, OB, OC or OD are totally removed after the section plane cuts. And hence, we can start our development from any point of our choice. It could be A or B or C or D. So let me start from point A. This is A, B. This is 30, BC 30, CD 30 and DA again. This TL, friends, stands for the true length of the slant edge. Why true length is required? Friends, whenever we make any development of any solid, we make use of the actual lengths or the true lengths or the true sizes. And if you observe here, friends, O dash A dash is the front view of this slant edge OA. And since OA is parallel to VP, O dash A dash represents the true length. This line is the true length from O dash to A dash. That is what I have taken here. And taking O as center, OA as radius, which is equal to this true length, I am going to strike an arc. And on that arc, I am going to step off 4 distances, each of 30. 30, 30, this is 30, finally DA is also 30. This is how the development looks when the object is not cut by any section plane. If it were a pentagonal pyramid, you would have got one more triangle. Hexagon, 2 more you would have got. And now friends, let us see where all the section plane is cutting the solid. If you consider S1, S1, this slant edge O dash A dash is cut here. O dash A dash is the true length. So we can take from this O the distance equal to this O dash to this point and mark on OA. Say friends, I am marking here. This is one point again on OA, same distance. Then friends, OB and OD, this point is B and D. So I will mark it as OB and OD. So this is OB, OD, B dash, D dash. So here friends, these are cut here. Where is that? That is exactly in between. That is cutting here. And if you see this OB and OD, they do not represent the true length. Hence, this point has to be transferred to the true length and take that measurement on OB and also on OD. So, both on OB and OD, you are going to have the same measurement. And obviously, this is going to be parallel to the base. I will show you. Friends, finally, the last slant edge, namely O dash C dash, is cut at this point. And friends, here, this is the true length because OC is parallel to VP. Hence, O dash C dash represents the true length. So, I have marked that point also. That is to be marked on OC at this distance from the vertex. So, this is the point. Friends, in all the pyramids, cubes and prisms, whatever the points you get there are to be joined by straight lines. So, I am going to write a straight line here, second straight line, third, fourth. And if you observe the front view, the full base is not touched by the section plane. Hence, I should show all this complete base, which are all straight edges by straight lines. And each of these have a length of 30 millimeter. And friends, let us mark them here. I will call this point 1 on OA, 2 on OB, 3 on OC, 4 on OD, and again 1 on this OA. So 1 is on OA. So this is going to be point 1 and this point is going to be on this. We did not show. So friends, this we have got 1, 2 and 4. So on OA it is 1, OB it is 2 and OC it is 3. This point is 4. So 2 on OB we have drawn, 3 on OC, 4 on this and finally. And the distances below that like 1 to A is retained. So I am going to show 1 to A by a full line. Similarly 1 to A here also shown by a full line. Then 2 to B. 2 to B again to be shown by full line. 3 to C. And we have this 4 to D. And friends, all this you have to show by full lines or visible lines. Friends, if you observe in the development, this total thing will give you the development of P, which is P, the portion below this cutting plane is the part P. And this is how we obtain the development of the square pyramid. And now friends, you can see here, so after getting all this, we have to show these lines from the vertex to this point 1 to 2, these three, all three to be shown by very thin line, making use of HR2H pencil. And this will give you the complete development, friends. Friends, I hope the presentation was interesting, and please go through the complete video. And many of these channel viewers, more than 90%, have not subscribed to my channel, and out of the subscribed persons only 10% are watching my videos. So I request you on this occasion to all the non-subscribed members to subscribe today and help me to grow this channel. Thank you friends. Thank you for watching my YouTube video. Have a wonderful day.